Hi, and welcome back to Mathemagics. Today we have a pretty interesting problem about probability. Let's take a look. So, a soccer coach determines that there's a 50% chance that a star player, Ralph, will play in a tournament. The probability that another star player, Dan, will play is 48%, or 0.48. The probability that both Ralph and Dan will play in the tournament is 0.25%. Select phrases to complete the statement. Define the probability that either Ralph or Dan will play in the tournament. First add blank, and then blank. And we've got a lot of options for all of this. So let's actually rein it back a bit and talk about probability in general. Now, this is a probability addition problem. And probability addition basically works. If you want the probability of an or type event, so the probability of A or, that's what the little u means, B, it equals to the sum of the two probabilities separately minus the sum of both happening. That little upside down u, that means and, all right, in probability terms. So there's, you get little bits of information, sprinkled throughout. The u means or, the upside down u means and I finally figured out how special characters work in all of this, but I still don't know superscript and subscript. Anyway, not important. Moving on. So, we need to use this information that we now have down here, and we need to fill out what we have over there. And let's say you don't know this formula off the top of your head. Okay, we'll get into kind of the how to figure that out in a little bit. So our options for the first blank, we're adding 0.5 and 0.48, 0.5 and 0.25, and 0.48 and 0.25. So, you need to be looking at those. Let's say you don't know anything. All right, you're like, you need to add two things together. If you want to add two things, you probably want to add Ralph and Dan. It would make sense that you want to add Ralph plus Dan, right? So we have a separate Ralph and a separate Dan. The Ralph is 0.5, and then Dan is 0.48. And the combined is 0.25. But it wouldn't make sense to add the combined and not Dan or Ralph. So you don't definitely want to use that 0.25 in the first one. Therefore, anything that uses at 0.25 is completely useless, right? So the first option has to be 0.5 and 0.48. But going with the mathematics, we have the probability of an A and B. Let's say A is Ralph, B is Dan. The probability of A is 0.5. Probability of B is 0.48. So you have 0.25 is the probability of both. So you have 0.5 plus 0.48. Super, we have that. We just figured that out. And then we subtract that 0.25. It's the only number we have left. So we look at our options. We subtract 0.25 from the sum. That sounds pretty good. I like that. Multiply the sum. I don't know why you'd multiply by anything. Divide 0.5 by the sum. Now, you might be thinking to yourself, well, wait a minute. Dividing sounds good. I like dividing. But then notice it's saying divide by 0.5. 0.5 is the probability for Ralph. But you've already used that number. Why would you need it there? And then we subtract 0.5 from the sum. But why would you add 0.5 to 0.48 and then subtract it? There's no reason to just do that because that just negates what you just did. Multiply the sum by 0.25. Now, this is the one that makes a little bit of sense if you're thinking about it. So, obviously, the answer is still subtract 0.25, and I'll put the answer, it's down there. I'm still learning which direction it is on the camera. So, we have the answer down there. But we're looking at multiply the sum by 0.25. That makes a little bit of sense, because multiplying by a number less than 1 will reduce your answer. It will make your answer smaller. However, when you're adding two things together, multiplying after that, multiplying something that is kind of the sum of both, doesn't really make sense. Think of it like a Venn diagram. You have two circles. All right. I wish I had two circles, but you have two circles, and they have a probability in each. But if they overlap, that overlapping part right there is the combination. If you want the sum of the whole thing, all right, if you want the sum of the whole thing, you take these two numbers and subtract that bit in the middle that they both count, because they both count that, right? That 0.25 is part of the 50%. It's part of the 48%. And that means and the reason we subtract is because you're counting that 25% twice. You're counting it in the 50 and the 48. So you need to subtract that 25. Otherwise, if you just add the two, you're going to get 98%. And it doesn't make sense that if you have a coin flip odd, 50%, and a second coin flip odd, 48%, the combined probability wouldn't make sense to be almost 100%, would it? It doesn't make any sense whatsoever. So that's why you subtract it. Now, obviously, it's very likely. You see in the bottom, we have 0.73. That's the combined. But you'll also notice the problem didn't ask us to find that. It doesn't care if you know the exact formula or not. The exact formula is not what they're testing here. They're doing basic probability. And the Venn diagram concept or the mathematical formula both get you to where you're trying to go. And that's another cool tip, our little unrelated tip. Some of these questions are asking very specific information, but rarely will one of these problems ask you to specifically find a formula that isn't on the reference sheet. And we're going to do a whole video on the reference sheet later, and we're going to talk about different kinds of problems that the reference sheet will allow you to use. It mostly has formulas for volume, but I believe it actually does have this specific formula on it. So we'll talk about that later, but this is all I have for today. So again, thank you so much for coming and listening to this quick little video. Hopefully this will be another problem that you'll get right. We'll see you next time. Goodbye, everyone.